Hi everyone, I am Mu'min Abu Ghazala. On behalf of the author, I'm going to present DAT, Data Architecture Tool for IoT. DAT is Data Architecture Modeling Tool for IoT application that describe how data flow through the system from the generation to the data consumption. DAT has the ability to provide two levels of data architecture, high level, abstract level, and low level, details level. The description includes data format. The data format could be structured, relational form, row and columns, semi-structure, emails and SMS and HTML, and structure, multimedia, office file, data processing type, storage, analysis type, and a way to consume the data. The idea from the DAT is to provide a data architecture tool that makes decision based on data easier and accurate. For IoT sector, we have different data sources and the data in different formats. We need to make sure that the data will be transformed to a unified format. Moreover, the data is generated at different speed that need to handle the scalability and reliability of the provided data architecture. In general, data gives the ability to describe the data to make sure the data will be transformed into valuable information. In our previous work, we developed a CAPS, an architecture-driven modeling tool for the development of situational-aware cyber-physical systems. CAPS focus on three views. These views are software, hardware, and physical space. CAPS and DAT are built on the conceptual foundation of the IEEE 42010. It is international standard for systems and software engineering architectural description that focus on the data view to give stakeholders like data architect, data science, and data engineer the ability to use model to specify different concerns such as data flow, data pipeline, data lifecycle, and data quality. That is built based on meta model that define the modeling language in which the model can be expressed. Our data model conform to the data meta model, which means that the generated model is an instance of a meta model. We used Eclipse modeling framework, which contain EMF core that include a meta model for describing the model, EFM editor that contain generic reusable classes for building editors for EMF model. GMF is a framework that provides a generative component and runtime infrastructure for developing graphical editors based on EMF. Eugenia is a tool that simplifies the development of GMF-based graphical model editor by automatically generating the GMF graph, GMF tool, and GMF map models needed by GMF editor from eCore meta model. As a tool interface for that, we have on the left side models, so we can create new model. In the middle, the graphical editor, and the palette, drag and drop data menu items, which contain objects and links. Objects include every element that we need to describe the data, like data processing, data formats, location, storages. And links to show a data flow between elements, the order of the data elements. We have three kinds of links. Links between data node and links between data elements inside the data node, links between data ports and send receive elements. And finally, we have properties to add, edit information about element like name, type, other useful information. As a result of our tool, we have simple example model. It is high-level architecture that show the data flow from the source to the final destination in one single data node. The first three elements are IoT devices represent as a data source. Then data ingestion phase that collect data from the sources and store in the data lake as a raw data. Then the processing phase, which contain two types, real-time and batch processing, to convert the data to another form to be ready for another use. Another example is low-level architecture. It is a part of one of real cases. It shows that the data source could be RDS, relational database, DynamoDB, API stream data. Then we have two processing data node, batch and real time, that extract the data and save it in HDFS file or file system. We'll add some data like financial, time, sales data, and publish to be transformed later to column-oriented. Now let us see a short demo for our tool. For the evaluation, we have 5 real cases evaluated. 4 cases done by 7 industry professionals are from 2 companies of different domains and researcher to check expressiveness. The last one done by 18 students to check ease of use. The evaluation was in terms of agreements and suggestion for improvement. One of these evaluation was an operational data warehouse. They shared with us a description that represents their case. Then we used that to model their case. Then we had an interview to discuss how much the model represents their case, and the result after evaluation was we agreed that the DAT was able to describe the details of their case, and the model is easy to share and understand by team members. The model was a good communication language between team members. As a suggestion, we need to show specifically the interaction between data nodes, not just send and receive. We need to cover all data interaction patterns like request response, publish, subscribe, pull, push, and other. Another case was a hider. In this case evaluation, we tried to see how much our tool able to describe big data architecture pattern like a lambda, kappa, delta, zeta, and other. And this case was represent a lambda architecture. And because of lambda, focus on data processing by taking advantage of both real-time and batch processing. It was useful to have elements that describe real-time and batch processing. The model represents very well the case. The indication about when to store the data on the disk are very useful. Especially, we are working with people that do not know the details of each technology. And as a suggestion, it is similar to previous case evaluation about interaction pattern. Same thing for other evaluation. And we were improving our tool after every evaluation. For example, providing high-level and low-level was after getting feedback from practitioner, and moreover that was easy to provide a data architecture solution, adding simulation data to data pipeline. As a suggestion was, it is good to have a data quality metric. A conclusion I concluded that is an architecture description and association modeling platform for data architecture for IoT. It is implemented on top of Eclipse modeling framework. Future work, we are trying to finish the evaluation with other companies. More evaluation means strong tool, and try to improve the tool to include the suggestion from the back practitioners, integrate with other existing technologies and tools. Thanks for listening.